Okay, so today we're talking about proportion word problems. The first thing I want to go over is what a proportion is. So if we have something like this, 3/10 equals 6/20. We call this a proportion because we have an equal sign and we have two ratios or two fractions that are equal to each other. Occasionally you'll see problems like on a standardized test or something which are kind of like false proportions. They'll give you two ratios and they'll say like 3/10 and 4/20. And they'll ask you like, is this a proportion?
And you say,
Is that a proportion?
no, no.
What they're really asking is, are these equal? The answer in this case is no. Okay. So we're not going to talk too much about those problems today, but just knowing the definition of a proportion as two fractions or two ratios that are equal will help you with those problems. Okay. In algebra, proportions often look like this. X over, let's say 5 equals, let's say 9 over 50. So what's different about this, we still have two fractions. We still have the equal sign, but we now have a variable. Right? And I like to use X, partly because Y drips below that line and doesn't look as neat. So X's are great for proportion word problems. The way that we solve these in algebra is to do something called cross multiply. When you cross multiply, I like to draw this little diagram. You multiply the top of your left-hand side times the bottom of your right-hand side. So that's x times 15, which is 15x. Right? I'll write it here as it looks. Then we put an equals sign, and then we do the bottom of the left-hand side times the top of the right-hand side. So that's 5 times 9, which is 45. Okay. Then as we talked about in the daily bites, we can solve this just by dividing by 15. I'm going to divide both sides of this equation by 15. This step may be new to some of you, but just remember to think about it as 15 times what number equals 45. So think of this as a little open box, if that helps you, because you've done more problems like that. Or if you're more used to this, just divide both sides by 15. 15 divided by 15 is 1, so we have 1x on this side, or just x. 45 divided by 15 is 3. So if I saw a problem like this and it said solve, or solve for x, that would be the answer. Okay? Hold off for questions until the end, okay? All right. Let's do one more example like that. Say I had x over 20 equals 7. So I see an x in a proportion, I automatically think cross multiply. X times 5 is 5x. I'm just going to go ahead and write it like that in my first step. 20 times 7 is 140. Right? It's 2 times 7 plus an extra 0. Now I have to solve for x. This is a type of problem where if you are trying to think what times 5 equals 140, it might be a little bit trickier than if you just divide both sides by 5. Technically it's still the same thing, but for some reason to me, 140 divided by 5 I automatically know, okay, I'm going to go like this. 140 divided by 5, and I'm just going to do long division. Because I don't know off the top of my head what that is. So 5 goes into 14. Let me make sure this is on the video. Yep. 5 goes into 14 twice. 2 times 5 is 10. 14 minus 10 is 4. Bring down the 0. 5 goes into 40 8 times. So I have x equals 20. So I've solved a proportion. Questions about solving proportions? Yeah.
Usually in tests will be it's basically just ask you what is x.
Yeah.
Okay.
Yeah, if we say solve for x, we're saying find out what x is. Another way of saying it is if you have x all alone on one side of the equation, what's left on the other side of the equation? Yeah.
Also, do we have to do it this long way, or could we just do like, okay, I see that 5 times 3 is 15, so you're gonna just do 9 divided by 3.
Uh-huh. Yeah, so there are some patterns with proportions, and I love it if you see a pattern and you can use it. So, right, 5 times 3 gives you 15. So x times 3 has to give you 9. So you could solve it that way. You could solve this one by saying 5 times 4 gives you 20, and 7 times 4 gives you 28. Totally welcome to do those that way. It's just not gonna, it's not 100% a way to solve a proportion, right? You may not see the pattern at first. If the numbers work out to be like small decimals or weird fractions, chances are you won't see the number that multiplies. So this is kind of a more algebraic or general approach to solving a problem. But if you notice this pattern and you can do it that way, you might guess. So the title of today's lecture is Proportion Word Problems. Let's look at a word problem. And this is what's on your homework.
So none of those probably use
No. Okay. This says if you can buy 1 can of pineapple chunks for $2, how many cans can you buy with $10? Okay, the key to these types of problems is that the first step I do when I look at a problem like this is write a proportion in words. So I can buy 1 can. Here's my first piece of information. And that can is for $2. So I'm comparing cans to dollars. Then they ask me how many cans. When you see this phrase how many or how much, this is going to generally be X in your equation. How many cans can you buy with $10? So they've given us more information about dollars. First thing I'm going to do is set up a proportion in words. So I know that I'm comparing cans to dollars. So my word proportion, right, my generalized proportion is cans over dollars. Now I'm going to look at the first half of this word problem. They told me 1 can is $2. So I'm going to set up the proportion of 1 can over $2. Okay. Equals, and I have to keep cans up top and dollars down bottom. I only know the dollars. $10. What do I put here for cans?
5.
Yeah. X. Now I have a proportion that looks just like those proportions we just saw. So what do I do? Cross multiply. 1 times 10 is 10. 2 times x is 2x. I want to get x all alone, so I divide both sides by 2. And I have 10 divided by 2 is 5. 2x divided by 2 is just. I'm not done. This is a word problem. They asked me a question in words. So I want to give my answer back to them in words. The question was, how many cans can you buy with $10? The answer is 5 cans. Or you could write, you can buy 5 cans. I'm fine if you just write it like this. It does not have to be a full sentence. Yeah.
No, it's food. It's
This
food.
is in New Hampshire, yeah.
Well, so, do you have to rephrase the question in your answer?
You
Or
do
is
not.
it just-
So you can just say 5 cans. As long as you put it in words like that, I'm fine.
So you don't have to put.
Yeah.
If it's like, this sort of problem wasn't necessarily big numbers and hard to figure out. If you could just figure it out with looking at the numbers and just put 5 cans, and you just do that without having to make the cross multiply.
Yeah. So sort of the same question that was asked earlier, right? If you notice this pattern of 2 times 5 equals 10, 1 times 5, oh, this has to be a 5. You can totally use that pattern. Now, that's actually how I would probably solve a problem like this, if I were to notice the pattern. We're just doing it this way because it's more algebraic and you're going to need this process later.
I think it's really important for you guys to be able to set the problem up,
Yeah.
right? Because I think what Nate's showing you is the information is really important, right? Those cans over dollars, right? It's kind of like, I know, Bella, what you're saying is that you can see the answer right away, but it's also good practice to set up a simple problem so you can make sure to set it up the correct way, right?
Yeah, if you had this problem, right, or a new problem on the homework, and you just wrote, 6 pineapple chunks or whatever, you would not get full credit for that because you didn't show any of your work. As long as you can show your work on the page, it's fine if you notice a pattern on one shorter. But what Joseph's saying is also really important. If I don't see that problem set up, I'm going to assume the worst, right? I'm going to assume, oh, you just guessed. You just wrote down a whole bunch of guesses, and you don't actually know how to solve these, and you're really, really lucky, and that's why you got all of them. All right? So please show your work. Yeah.
So even if you can just solve it by looking at it, you still have to show it.
Show at least the setup, right? If you solve this a different way, that's fine. Right? In algebra, there's always a million ways to solve a problem or an equation, right? I could multiply both sides by 10, and I would get the same answer as we got. So it doesn't matter to me how you solved it, as long as you show your work. Okay. We are out of time, guys. Thank you.
You're welcome.
Do not go anywhere. I need to turn